Hi students, this is our second lesson for the topic of functions, and this is for the International Baccalaureate course Analysis and Approaches. In this lesson, we're going to look at reciprocal functions. So a reciprocal function is of the form y equals k over x minus a. And you can see why it's called a reciprocal function. This is upside down. We've taken the reciprocal of x minus a. Let's show that xy plus y minus 1 equals 0 is a reciprocal function. All we have to do is make y the subject. We'll start by taking this term over the other side, factorising the y out, and dividing both sides by x plus 1. Now, because this is in this form, this is a reciprocal function. The graph of a reciprocal function is called a rectangular hyperbola and has some specific characteristics. There are two parts to the curve, and there are two asymptotes. That's these dotted lines here. Now recall, an asymptote is a line that a curve approaches but never touches. Now this function here, this would be y is equal to k over x. Now one way to graph a hyperbola is to draw up a table of values. And you can see that when we get to x is equal to 2, we run into trouble because 2 minus 2 is 0 and we can't have 0 in the denominator. And this is our vertical asymptote. If we plot points, we're going to end up with a curve that looks like that. And we can see that there is a horizontal asymptote at y is equal to 0. Let's have a go at writing the equation of the asymptotes for these hyperbolas. So we've got y is equal to 2 divided by x minus 3. Now, it's pretty easy to figure out the equation of the vertical asymptote. X can't equal 3 because we can't have a denominator of 0. So there's our vertical asymptote. Now, the horizontal asymptote, y can never equal 0 because there's no value of x that is going to make this fraction into 0. So the equation of the horizontal asymptote is y is equal to 0. How about this one? Vertical asymptote, x is equal to negative 1. Horizontal asymptote, again, this can't equal 0, so y is equal to 0. Now it's annoying to draw up a table of values if you want to sketch a curve. Instead, we can use the features of a curve to sketch it. And this can include x and y intercepts, turning points, asymptotes, the direction or orientation of a curve, and limits. Let's have a little chat about direction or orientation. We have positive curves and negative curves. A positive curve is going to exist in the positive quadrant, which is this first quadrant here. And the way to tell from a function if it is positive or negative is to look at the highest power of x and to see what sign it has. So this is a positive curve. Now, a negative curve will probably not exist in the first quadrant, but it's not an exact science, so you need to practice some of these questions. It's going to exist in a negative quadrant. The way to tell is to look for the highest power of x and see its sign. Can you see what I've done here? I've written a tricky question because the highest power of x is here and it's positive. But have a look at this minus on top. Really, we need to put that minus through the denominator. So I could write this as 1 over negative x take away 1. It is definitely a negative curve, and this one doesn't exist at all in the first or the positive quadrant. It exists in the negative quadrants. Now let's look at this example and we'll pick up the features from the graph. In this case, the y-intercept is the point 0, 1. There are no x-intercepts. There are no turning points. There is a vertical asymptote. It is at x is equal to negative 1. There's a horizontal asymptote at y is equal to 0. And this curve has positive orientation. So let's use all of that knowledge to sketch y equals 2 over x minus 3. We'll start with the vertical asymptote, which is going to occur at x is equal to 3. We have a horizontal asymptote at y is equal to 0 because this can never equal 0. We have a y-intercept. When we substitute x is equal to 0 in, we get y is equal to negative 2/3. And we have a positively oriented graph. So when we draw it up, it looks like that. Now hyperbolas do appear in real life. Here the function's been used to create the shape of this smokestack, and it'll also be the shape that occurs when a light is against a wall. So let's look at an application. A school hires a bus to take students on a field trip. The cost of the bus is $280. It can seat a maximum of 66 students. Write an equation for the cost, C, per student if there are n students. So we're going to take our $280 and divide it by n. There's our equation. B, what is the set of permissible values for n? Now this is called the domain of the function, and we're going to get to that in our next lesson. Well, when we think about this, we can have all the way up to 66 students. It's not sensible to have 0 students, but we could have greater than 0. So n could go anywhere between 0 and up to and including 66. C, what is the cost per student if 45 students attend? We just substitute that into our formula, and it's equal to $6.22. D, the school wants the cost per student to be below $5. How many students must attend the excursion? So this time we're going to substitute in C is equal to 5 and solve. We need 56 students to attend. Okay, that's it for this lesson. In our next lesson, we're going to look at domain and range.